Well, good afternoon, everybody. Well, it's almost good evening now. I hope you can understand my English, and I'm glad we managed to get our connection sorted out. First of all, I have to wish you congratulations on your 75th anniversary, which I understand is very soon. And I'm very pleased to have been invited. Thank you, everybody, for inviting me to speak today. It's a beautiful day here in Cambridge. I hope you have the nice same kind of weather as us. And apparently it's also Earth Day, so it's very suitable that we should be talking about issues which impact on the natural environment and our human interactions with it. So I've been asked to talk today about the Anthropocene, this relatively new concept which has become so popular in the press and popular media in general, and I hope to give you some of my views, at least, on this topic. I'm speaking, of course, as a stratigrapher and a geologist, like many of you, and I hope that you'll be aware, therefore, that I have some kind of a biased opinion, but I hope you'll forgive me for that. And you can question me at the end if you disagree, of course, or if you have more points to make. So I hope this lecture is of interest and gives you some new insights into this whole rather thorny problem of the Anthropocene. And of course, it's, as I've said, it's already gaining considerable popularity with the media. Here's a sign which has been put up in America. Of course, they've got this stratigraphical terminology wrong, because it's never going to be an era, which would be equivalent to a unit far larger in scale than the Anthropocene could possibly be. But it's, in fact, as you'll see, there's some discussion about whether it should be, what status this term should have. But we'll see that as we go along. You'll probably, some of you at least, be familiar with the fact that the term Anthropocene was suggested by Paul Cruzen, a chemist, an atmospheric chemist who died very recently. And he used the term because he thought of the impact of global environmental effects of increased human population and economic development. And he made the point that things have been influenced so much by humans now that we have left the natural conditions of the Holocene, as he saw them, and other Pleistocene interglacials, and that we're moving into a new phase dominated by our activities. And he suggested originally, as you see from this slide, that this period should start with the European Industrial Revolution, which of course is in the mid-18th century, and that was his proposal at the time. But of course, there are a number of issues. As geologists, you'll be aware of this, and how these are actually manifest, and how we are dealing with the need to define this term, if we're going to use it in a formal sense, is what I shall be trying to focus on today. The original idea that we had was published in this article, which was published in GSA Today in 2008, raising the question, are we now living in the Anthropocene, in response to the publications of Crutzen and others. And this article generated a lot of discussion, and at the same time, we established a working group in the International Commission on Stratigraphy, the Quaternary Subcommission, which I chaired at the time, to look into this whole question. And that working group, the Anthropocene Working Group, or AWG, as it's often shortened to, are still working on this matter today. So it's still not defined. There's still room for discussion and understanding of this whole principle. Now, I don't need to tell anyone who works in the natural environment that our activities are having quite profound impacts on the modern environment in terms of flooding, landslides, and other such activities, together with the profound changes in greenhouse gases, in ocean temperatures, etc., etc. As you know, there's considerable evidence to show that we're already warming the climate beyond normal natural conditions. As you see in these pictures, obviously the blue is low temperatures, the red higher temperatures, and that temperature distribution is not equal across the face of the Earth, but is concentrated in certain regions, particularly notably in the Arctic. And this, of course, is having profound effects on the melting of glaciers and sea ice in that region. And this is, of course, contributing to sea level change. And the big fear, obviously, is the melting of the Greenland or Antarctic ice caps could lead to global sea level rise. This is a rather fanciful constructions for sea level in the near future at about 6 meters. Now, we may think that this is excessive, but I would like to remind you that in the Eemian, which is the last interglacial 125,000 years ago, we had sea levels up to this height, and so it isn't inconceivable that we could have sea levels, well, at least above, several meters above present in the future. Maybe I won't be around to see it though. But of course, we've made enormous impacts on landscapes. Humans are effectively very important geomorphological agents, as I'm sure you understand. We're all familiar with the industrial landscapes such as we see in this picture. And also, of course, at the top right, you see the Netherlands, an area which was created by the Dutch rather than by God. And you can see that this cumulative effect is now covering very large regions of the Earth's surface. And also, not only are we making excavations or building new landscape from existing materials, but we're also creating new materials. And here are two examples of artificial materials: waste from our activities accumulating in fill sites, and also material of artificial origin, such as concrete or beton in this picture, and very interestingly, the conglomeratic material made of plastic of one kind or another. And of course, plastic waste is becoming a very, very serious matter, especially microplastics, which are turning up virtually worldwide. And these are creating new types of deposit. One example here. And of course, but the main material we've created is concrete, and the amount of concrete which has been created, of course, is accelerating at considerable rates. So this is cement production in this little graph in millions of tons per year. And you see this graph showing a steady rise since really the end of the Second World War. There are many other activities, of course, which are also increasing. As we've already mentioned, sea level, global temperature, you'll be fully aware of, is predicted to rise considerably in the next decades. Atmospheric CO2, all this is well known. Denudation as a consequence of anthropogenic activities such as erosion in rivers and so on. And of course, this is all linked to the exponential growth in human population. But of course, this is not geological evidence. To go back to the original definition, as I said already, was by Cruzen and Stromer in 2000 in their paper in Nature, was to suggest that the Industrial Revolution marked this departure from natural conditions. And you see in these two lower graphs, the one on the left showing the increase in atmospheric gases since the 18th century, and on the right hand side, the production of mineral magnetic pollution or soot particles resulting predominantly, of course, from burning of coal. And this is often pointed to as the point where we can identify human activity worldwide. But that's not the only impact of human activities. One of the more obvious is the result of alluviation, which results in river valleys being filled with alluvial sediments, which are derived as a consequence of forest clearance. This is particularly important, obviously, in areas which would normally have forested vegetation. And here are two examples. Well, one example, but two levels, which Tony Brown and his group back in 2013 suggested could be used to mark discontinuities which occur in Holocene sequences. And these thick sequences of alluvial deposits, of course, result from flooding. And that's a consequence of forest clearance and increased input into river systems. Another boundary which has been identified is this one around about 7,000 years ago, and this was pointed out by Bill Ruderman, the eminent climate scientist from New Jersey in the United States. And he says human impact from early farming and deforestation significantly influenced global terrestrial and climate environment from early in the middle Holocene onwards. And he shows two examples in this slide. We see the progressive increase in the area of cultivated rice in the Far East, and the irrigated and lowland land, which obviously again is increasing alluviation in these regions. So we have a progressive spread of rice agriculture, just as an example of the sort of thing that's been going on during the Holocene as a consequence of human activity. And on the right-hand side, you see three graphs. The upper graph is for methane. The one below is carbon dioxide in parts per million, and the forest clearance at the bottom in the third graph. And what these graphs show is the normal interglacial trend in the volume of these two gases. That's the blue line. And the red lines show how in the Holocene, the content of these two gases in the atmosphere has long departed from this blue line and blue envelope, and this is a direct consequence of our activities. And as you see, it rather closely parallels the view that Bill Ruderman has been proposing, that forest vegetation or clearance of forests is a direct consequence of this activity. And here you see the ice core record. So to give us a longer term view of what's happening at the present day, and the present day is on the extreme right, where we see the plots for both methane in parts per billion and carbon dioxide in parts per million, and the record back over 800,000 years, which comes, of course, from the ice core records. And here you see, although there's a lot of noise in this sequence, you can see that the present day plots are way above any concentrations that we've seen over the last 800,000 years, and indeed a considerable time before that. So there's definitely significance in our activities, and and as you see on this scale of this plot, these have shot up almost vertically in this over the last centuries. Now, another point that's been made, particularly by Stefan, an Australian geologist and Earth system scientist, has shown that if we look at a whole series of different criteria that you see plotted here, including not just the greenhouse gases, but also flooding, biogeochemistry, biodiversity, ocean ecosystems and the like, all these things seem to show a marked increase in the last 100 years or so. And Stefan has christened this period the Great Acceleration. And when we look more closely at it, this Great Acceleration is really limited to the post-war, post-Second World War period, beginning in about 1950. And it's this great increase which people like Stefan and, in fact, the Anthropocene Working Group participants have identified as a potential boundary, that is to say 1950 or thereabouts. So there's definitely a lot of activity going on. I don't think any of us would disagree with that. And if we look at possible projections, this figure is trying to show you how in the next 100 years we might expect to see great increases, of course, in population numbers, and as a consequence, the great increase in carbon dioxide production and the global temperature rise, etc. So it's not unreasonable to make these predictions, but of course that's all they are. They're just predictions if we don't do anything. Although it seems that the politicians are beginning to understand that something has to be done about this. But that's not necessarily the problem of geologists. So let's move on. One of the things which is really serious, of course, about the late Holocene is the question of extinctions as a result of our activity. And this plot is trying to show you how in the major animal groups, mostly the vertebrates, of course, we are seeing serious extinctions as a consequence of human activity. These extinction rates have increased quite substantially since the mid 19th century, and are still apparently increasing at the present day. So the question, of course, therefore arises: are we living through a mass extinction event like those we've seen in the geological past? And if so, how is that going to impact on us as humans? And there's evidence not just from the animals, but also from the plants. Here is a pollen diagram, fossil pollen from a lake site in Connecticut in the United States, northeast United States. And you see there's a very marked change around about 1700, and that marked change is seen in a whole spectrum of weed and herb flora, not trees, just low-growing plants, particularly the ambrosia, which is a weed of cultivation, and that boundary is actually marking the European settlement and therefore the development of agriculture in North America. And it produces a very clear peak, but of course not a peak at the Industrial Revolution that we see in Europe, but somewhat earlier. And of course this peak it becomes later and later as we go further and further west in the United States and Canada. So therefore, I want to show you there what I hope is coming over, that there are a number of events which we can identify that show the impact of humans. And here are 9 examples which come from originally from a figure by Lewis and Maslin, 2015, and modified by our Australian colleagues. And here you see in the red box in particular, the number of, or the series of possibilities which have been proposed, which could be used as an event to mark the beginning of a possible Anthropocene time division. I'm not going to go through all of these because not all of them are being considered now, but you see these include the colonization of the Americas, which you've just seen some evidence of, the Industrial Revolution, which is Crutzen's original suggestion, the Tambora eruption, which was a major eruption, which sent sulfate gas around around the whole Earth. That was in 1815. And then this great acceleration, which I mentioned, many local events post Second World War. And the final example there is the nuclear weapon testing in the atmosphere, which of course began in 1945 and then continued into the early 1960s before atmospheric testing was stopped. But this, of course, also provides a useful horizon if we want to identify a boundary at that sort of time period, that is to say about 1950 or so. But if we look at the Holocene in general, and this plot actually includes not just the Holocene, but also, as you see, the late glacial, which begins around about 10,000 years ago, you can see that human activity, it's in German, but I hope you can read it, human activity has been going on pretty much through the whole of the Holocene. And indeed, one of the reasons for defining the Holocene as a separate interglacial from the other interglacials which occur in the Pleistocene is the activity and presence of humans. So you can see why, but you can also see here a number of examples which could be identified to show human activity even beginning before the present interglacial began, so over 12,000 years ago or more. The Holocene division, which is relevant to our discussions, was what was proposed back in 2009, and a subdivision of the Holocene, which was ratified relatively recently in 2012, has been published in the Journal of Quaternary Science by an excellent working group of the intimate subcommission of INQUA, and there's a couple of references there for you should you wish to look at the details. It's all fully published. The basal boundary of the Holocene is defined in an ice core. This is a unique boundary definition. It's the North Grip core, which occurs right in the center of Greenland, and there you see the conditions of and an ice core, the ice core itself actually, in which the boundary was defined. The boundary is defined at this point 1492.45 meters in the ice core. This is a reversed image because it shows the detail better than a positive image, but you can see that the boundary is there fixed very clearly by the laminated structure of this ice core, which can be used. It's annually laminated, and therefore we can count backwards to get an almost precise age. And if we do that, and we can look at a number of parameters, but if we do that, you see that the base of the Holocene is defined at 11,703 years before the year 2000, and that gives us a very strongly fixed boundary. And even if that's plus or minus 50 years, that's still probably the best defined boundary in all of geology. Here you see the ice core being held up by this person, and so how do we go about defining a formal boundary, should we wish to, for the Anthropocene in the same way as we've done for the Holocene? Well, the answer is it has to be defined formally. And when we look at the name, which is just an invention by Cruzen, we see that it has this "scene" ending, which implies meaning new, of course, which implies epoch or series rank, which would make it equivalent to Holocene, Pleistocene, Pliocene, Eocene, etc. But why? Is that the appropriate rank, or should it be larger or smaller? We can discuss that point, and it has been discussed, but the assumption is that it should be of epoch status, and this is the work of the current working group. Their proposal is that would therefore require what we call a GSSP, or a global stratotype section and point. That is a boundary marker which is of global significance. And sometimes these GSSPs are called golden spikes, as you see in the corner. I'll explain that in a second. Or some boundaries have been defined not by a GSSP, but by a GSSA, which is an age, a standard age, but this is not popular with the Geological International Union, because we wish to define boundaries in rocks rather than by defining them simply with a date. But as you see, 1950 is already a date which people have centered on. Anyway, if the Anthropocene is to be of defined in this way, that will decouple it from the Holocene. In other words, it would post-date the Holocene. And the questions we must ask, therefore, are, is this justified and is it desirable? And when we're asking these questions, remember, we're geologists, we're not historians, and we are not social scientists. The Holocene, as you've seen, the Holocene basal boundary in the picture was defined in 2008, and that is already established. A lot of work has been done then by this working group, and this began really with our group in Britain, here in London, the Geological Society of London's working group, and a number of papers have been published. This is an early one, but there are many more subsequently discussing all aspects of this and how details might be used to define an Anthropocene, should it be felt necessary to do so. But as I must stress that if it's going to be defined as a chronostratigraphic unit, and this is the critical point, like all the other divisions in the geological timetable, it must have a geological marker. So what geological marker are we going to choose? And as I've already suggested, the Anthropocene Working Group has focused on 20th century atom bomb testing, the radioactive surge which came from that, and is indeed preserved in sediments, and as a marker which could be identified all around the world. The question of this so-called golden spike, or GSSP, I want to develop a little bit further, just so as you know what that precisely is. Here is on the right is Jürgen Peder Stefansson from the University of Copenhagen, and he's holding the core in which the Holocene is defined, the base of the Holocene. And as I mentioned earlier, this is the first time an ice core has been used as an international reference. But to show you a more typical GSSP, or a golden spike, we have to go to the other end of the timescale, to the Precambrian. And here is the base of the Ediacaran stage, which is defined in the mountains in Australia. And there you see a typical GSSP marker, which is ratified for the beginning of this stage. So all the strata above that level are of Ediacaran age. Other lines of stratigraphical evidence which have been proposed. One is a very interesting one, is this so-called Teufelsberg Formation, which is a series of hills which are actually waste accumulations which were produced by from the debris of bombed out buildings and the like in Berlin following the Second World War. And now you see they look like rather pretty hills, but in fact they are all man-made, these structures. But of course that does give us a lithological unit which we can identify and even map in that locality. But as I've said, the favoured boundary is a result of the atom bomb tests which began in 1945 in New Mexico. So can these radiogenic signatures define the initiation of an Anthropocene stage or beginning epoch? And there's some detail here which we don't really have time to go into, but basically if a golden spike in sedimentary succession is used, it is more likely to have a persistent signature in soils from 1952 and that's plutonium, Pu, 1954 in cesium, and in radiocarbon 1955, and from and so on. So there are a number of radiogenic signatures which could be potentially used, but the question, of course, is that boundary at the place we want to define this unit, and that's another question altogether, which we'll see in a moment. So should we then therefore establish a formal boundary, and if so, if we can use a GSSP, well, that would be fine, or we can use a date, which needs, but both of these need to be accepted and approved democratically by the International Commission on Stratigraphy. And in fact, all geological boundaries of this type, from the Precambrian to the Holocene, have to be defined and approved by the International Commission, and a process which has been in progress for several decades. And it should be possible to select a unit, but hypothetically we need a point intersection or a date that coincides with the end of the pre-industrial Holocene for this to work properly. But the big problem here is that as we know from our history rather than from geology, the beginnings of the Industrial Revolution do not necessarily, as I've shown you already, mark the beginning of human impacts on the natural environment, which are, of course, continuing to this very present day. So we must be very careful where we select this boundary. One of the proposals, there are no specific sites which have been selected so far, individual sites rather than these possible identifying a possible global sequence. Well, one of the sites which is being worked on at present and which has been put forward as a potential candidate is a lake core from a site called Crawford Lake in southern Ontario in Canada. Why has this been chosen? Well, it's been chosen because, as you see on the right, the sediments are annually laminated. And in this case, those annually laminated sediments can be counted, the annual laminae, and an age can be proposed. And where you see that color change in the core, from the brown color at the bottom to the darker gray higher up, is the contact where people are proposing to draw this boundary. And you see the diatom, pollen, and geochemical signals from this core show a change at this point, which is shown by the red line. And so this has been thought to be a very useful locality for defining this boundary. However, there's why one should choose a lake in southern Ontario, well away from industrial areas, is another question, and we might discuss that point, whether this is a suitable boundary site, given that we have to be able to correlate this globally, not just find it at one locality. But nevertheless, you see this red line at 1950 certainly shows some significant changes in the assemblages in this core. There's the boundary there. And well, we've covered this point really already. This is the question about defining a golden spike. I can't stress this too much, that if we're going to define a boundary for the base of the Anthropocene for geological purposes, we must have a point where we can identify it with a golden spike and therefore a GSSP. Some of you may be wondering where this term golden spike comes from. The term is derived from the building of the American railways in the 19th century, and the point at which the transcontinental railways met each other, one coming from the west, the second coming from the east, and this point in Utah on the 10th of May 1869, a ceremony was held, which you see in this picture, and a golden spike, that's a nail which is put in to hold the track. The last spike put into the track to hold the railway line in place was a golden spike to commemorate this this boundary. I imagine the golden spike is not there anymore, but you can see a facsimile of it. But anyway, that's where the term golden spike comes from. There's a moving on, there's a huge literature which has been developed over the last couple of decades on this whole concept of Anthropocene. It's taken off completely. Originally, it was a concept which was mainly controlled by the geological community, but it's become so popular, particularly with the humanities, workers in the social sciences, and even in history, that a whole series of books have been produced, a whole series of publications. Many of them, they're not all in German. There are publications in many languages, but particularly, of course, in English. I could go through showing you many, but I won't waste too much of your time. But one of the things that emerges from all these publications is that there's no definition of the term Anthropocene. It appears that many people are perfectly happy to use this term without considering what it actually means. And it's taken on a meaning, of course, to represent human interaction and disturbance of natural systems. But in fact, if it's going to be used in geology, that's simply not appropriate. But that doesn't seem to stop the workers in many fields from using this term in a very general sense. So beware this term, really. I joined this discussion back in 2013 with an archaeologist, a very eminent man, Bruce Smith from the Smithsonian Institution in Washington, United States. And we had a discussion online, and it emerged that Bruce Smith, who'd worked in Latin America, was very keen that the Anthropocene should be defined much earlier than had been proposed by people like the working group, not the Industrial Revolution, not the nuclear weapons, not the variation of human activity, not agriculture, but the rise of initial domestication of plants and animals, and possibly even megafaunal predation going back over nearly 14,000 years. Well, simply this is not going to work. The term Anthropocene cannot displace the term Holocene or any other terminology which is already established, because they're already established. And therefore, the Anthropocene, if it's to be used to be directly equivalent, for example, to the Holocene, well, that simply cannot be. That's not allowed by the rules of stratigraphy. So there are a number of places where we can define a boundary, and yet, and we know that humans have been active because we've seen the evidence, and you probably know quite a lot about it too. But our colleagues in the working group are convinced that it should be here where the red arrow is, in 1950, and not earlier. So what do we therefore do with the rest of the time, which is, of course, Holocene and late Weichselian, or whatever other term you wish to have for the end of the Pleistocene, the late Pleistocene. So this is where we stand. It's in a rather confusing situation, but Bill Ruderman has made a very valid point when he says, does it really make sense to define the start of a human-dominated era millennia after most forests in arable regions had been cleared for agriculture? A very good point, and one that's, you know, as you see from the plot there, that began at least 8,000 years ago in many parts of the world. And in a straw poll by one of my colleagues, Erie Ellis in North America, asking where colleagues thought boundaries ought to go, and this was just a straw poll, it has no great weight, but it's interesting to see that many people are undecided about where this boundary should go. Whether it should be very recent, 1950, or whether it should go back as far as the mid or even early Holocene. So agreement is still not reached. This is, excuse me, in this plot, you see the proposal that would be adopted and is favoured by the Anthropocene Working Group colleagues, led by my friend Jan Jelšević. And you see what would happen is that the Anthropocene would then be raised, if they have their way, to the equivalence of Holocene, and the divisions of the Holocene would be therefore separated from the present day by some unnamed, so far at least, unnamed divisions. That's their proposal at the moment, and that's what they're working towards. You might like to think whether that's appropriate or not. What is really against this definition of a series or epoch, that is to say, to define the Anthropocene at this very high level, is that it's neither based on fossils nor physics. Crutzen who's an atmospheric chemist, suggested it should start in the 1700s, as I've suggested. And that is a good choice to mark the beginning because of the carbon dioxide pulse, and it underlines the current global warming. However, this could not be determined using numerical dating methods, including historical records, because they're not geological records. If we're going to define a geological division, it must be defined geologically, not from external records. Excuse me, I'm choking. So, what about this whole question of diachroneity? We're familiar with diachroneity for sea level change or for tectonic activity or whatever you like to talk about, but there is also strong diachroneity in the development of agriculture, as we've already seen, and pastoralism. So, and if we define the boundary of the Anthropocene as up to about 60 or 70 years ago, all this evidence which you see before you here, pretty much, apart from that in the bright red colours, will be excluded. So, is it really a good idea to define an Anthropocene dependent on human activity so late, or should it be defined to include this longer period of time? I and my colleagues have an article in press, and we have, and this is hot off the press, as they say, and this figure attempts to show you the reality of the situation. It's a logarithmic scale, so please notice that it's 1 million years on the left and it's only 100 years on the right. But what we are showing in this figure, and what you've already seen me talking about today, is that human activity is diachronous. It begins in the late, the influences that we have, rather, it begins in the late Pleistocene, and of course it's continuing up to the present day and presumably will continue into the near future. And really just about everything we look at, and in as you see in the historical timeline there is diachroneity. So it simply isn't, it seems to myself and my other authors who've joined me in this article, it seems to us that to define the Anthropocene as a fixed period of time is simply not justified by the data and does not include all the evidence we have for human activity over the last, well, let's say possibly 50,000 years, if we include the megafaunal extinctions which began with the humans potentially beginning with human hunting in the end of the Pleistocene. So how are we going to cope with this definition? I'm going to leave that question hanging. I'm sorry for all this text, but since I'm talking to you as geological surveyors, there's one more important point we have to make. and you can just read the heavy text and leave the lighter stuff if you have time to read it. But as stratigraphers and mappers, we wish to map the Anthropocene with relevant and consistent meaning. How do we do that? And as Ortin and Holbrook pointed out in 2012, we are left to map a unit conceptually rather than conceptualizing a mappable, rather than finding a mappable stratigraphic unit in many instances. Of course, there are instances where we can identify human material, as I've shown, but that's not going to work everywhere, and it's going to be very difficult for geological mappers. And if you look at the lower paragraph, which again is a substantial piece of text, which I apologize for, but it's from an unpublished article from the Netherlands Geological Survey. And as I pointed out already, as they often say, God made the world, but the Dutch made the Netherlands. We are not able to map post-mid-20th century deposits. We would discourage declaring the Anthropocene at the epoch level, if not because it's perhaps too early to tell whether it is functionally and stratigraphically distinct from the Holocene, then because there is not yet a physical record. And just to emphasize that point, here are two geological maps of the Netherlands by the Dutch Geological Survey. The one on the left it does not include the Anthropocene, and the one on the right does include the Anthropocene material. The black dots, each of those are attempts to mark Anthropocene, concentrations of Anthropocene material. And of course, this is an extremely difficult thing to do in the Netherlands, perhaps not so difficult in some parts of the world, but increasingly so, obviously, if we're to find a way to do that geological mapping. It's far from solved at the moment. So that's another problem. And what about subdivisions of the Anthropocene? This slide is rather a joke, and you see it comes from 1993 by a now dead geologist called Derek Ager, who some of you may know is a Mesozoic geologist, worked mainly on the Jurassic, but he is very scathing about mapping this type of evidence. And this, of course, goes way before the Anthropocene discussion emerged, but he is pointing out that you can use beer bottles and beer cans and goodness knows what else for mapping human deposits, and even dividing them, using these materials as kind of technofossils, as they're now being called. So let's sum up what we've been talking about. Do we really need an Anthropocene? And what I'm stating here is what I stated right at the very beginning of our lecture. The case is not yet made for its consideration as a formal series or epoch. Whilst changes sufficient to leave a global signature are definitely present, can we tell this everywhere from our current perspective? There are certainly significant changes, but are they geologically reasonable? And can we find a golden spike GSSP locality from which to define this series? And are we happy to segregate the last few centuries to decades from the Holocene? A point I've made in a paper with a colleague, which is also in press, is this one. And as geologists, I hope you would agree with this statement. The fundamental requirement for the definition of a new division of geological time is that any evidence that is used to define a boundary and to characterize a unit must be preserved in the geological record, i.e. in deposits, or rocks if you prefer. Nothing else will do. And I think this is something which many people who wish to define an Anthropocene for various reasons, many of them non-geological, do not really understand. So if we don't define a series or epoch in a formal sense with a fixed boundary, what can we do? Well, the answer, I think, is to define an event. Those of you who are familiar with events such as the Great Ordovician biodiversity event, or the great oxidation event and various other geological events will know that one of the critical points about these events in geology is that they can have diachronous boundaries, unlike a GSSP, which has a fixed time boundary. So thereby, if we define an event, we can encompass all that period of time of human activity, and the term would not displace Holocene. We would still be living in the Holocene, but it could run in parallel with Holocene and have this distinct meaning, which is comparable to the other events which we find in the geological record, which also are not defined as rigid time periods themselves. This adoption of this term, we believe, will depend on its utility, of course, for geoscientists working on late Holocene successions, but at the same time, it would be very useful for our colleagues in archaeology, social sciences, history, and the like. And so I'm suggesting this as a solution to this rather thorny problem of defining what precisely the Anthropocene means. And here are more statements of that topic, just developing that idea, stressing the nature of diachronous sequences and the fact that we must allow for multiscalar distinctions, heterogeneity of processes, etc., etc. And also to work so that this division, if we're going to use it at all, has a meaning for our colleagues and a definition, of course, for our colleagues in related subjects who wish to use this term but do not wish to get into the niceties of geological correlation. I want to end with this slide. I don't particularly like this slide, but I wanted to show you that there is indeed a lot of criticism out there of the blanket definition of the or usage and application of this term Anthropocene. This is a very recent article which I encourage you to have a look at, not because I necessarily accept everything that this author says, but at least it shows that people are becoming aware that this blanket term is being overused and underthought about. And as you see, was very, very recent indeed. And there's the link at the bottom of the screen if you wish to explore what Mr. Sierpkowski says. So that's my presentation, which I hope has given you some food for thought, and which I hope you feel justified my delayed presence here today. Thank you very much for your attention, and again, I wish you a very happy 75th anniversary celebration. Thank you.